Dear friends, in this report, I would like to present formal outlines of case-based modeling of data and knowledge sources for drilling control. Is a problem of vast drilling for oil and gas is one of the main topics in our university that is very acute problem in the contemporary world because we have a lot we need a lot of energy, and oil and gas so far is the main source of such energy, and to make this process drilling more efficient, more rational, and more controlled is a main point of this research. On this slide, we presented some of levels of intellectual control, and it presents the main point of knowledge-based systems. Application in drilling is a very newest approach because new knowledges is using of knowledges is IT is a main trend of today IT industry. So the main point is to control feedback, and we have this feedback in the form of controlled variables, and these variables allows to make some guess about which variables is the output, and this can be controlled by right assignments values for controlled parameters. And to make such assignments, operators need some assistance because process running of the process life cycle is very different from the it is depends on conditions of drilling. From the where we drill is like in Ukraine is vast deposits of oil and gas, and in the most of Ukraine, so it's different conditions and different control. When we're talking about these controlled variables, we present it in the form of signature matrix. This matrix allows is constructed from the variables and parameters, and here we single out controlled parameters, uncontrolled parameters, disturbing parameters, and output results parameters. So signature matrix is as we will see is a main starting point, but the formal ground will be a case-based modeling, and here we present a case instance. This case instance is can be boiled down to value assignment is a very simple form of case, but the question is which would be these values that in every situation, every point of time, it would be different values, and knowledge base should help to take right decisions about it. If you previous slide, it will be a very simple situation, but in real drilling, it's nothing is so simple, and we need to approximate these cases, and such approximation can be made by some probabilities, and these probabilities will be assigned to querying case, and the querying case is some routine that would find most similar case to the situation of drilling, and that will be the base form of assistance of decision making support. And when we have a narrowed set of cases, we need to evaluate its cardinality, and this cardinality would allow us to make more a clear judgment about the probabilities, and probabilities would finally show the way to making use of probabilistic approach, because computers cannot direct dealing with probabilities. It's just it can be finally it can be 0 or 1 point. Is not nothing else like just we have in digital approach, but there is future maybe when we have quantum computers that will be different, but here that is only formal approach, and formal approach need to make some use of evaluation, and for this purpose we use utility function, and this function allows to evaluate similarities, and for this purpose we use singlet similarity function, and is dealing with mainstream of case-based decision support, and it's about cases of real data, but this data is different from every single state of the process, and even these states is very close. That doesn't mean that solutions will be the same. It will be very, very different. If we're talking about knowledge-based system and case-based approach for this modeling, so one of the points of our research is getting cases of knowledge, and this we're starting from a simple case where we have parameters and values, and on the upper level we have parameters on the input and the output, and some arrows that would connect it, so it is we can be use interpretation. Arrows interpretation is a form of rule, and rule is most widespread conception of knowledge, because we know that knowledges in knowledge-based system, that it was 19% or even more, is exactly a rule-based system. So we have here presented just starting from a simple case like in most systems. We have database, we have interface, and we recommend to kind of knowledge-based system, and this is 7 steps. 7 steps would allow from searching of retrieval of constraints, case regaining to activate knowledge-based entities, and on the next step is the solving routine, because a lot of cases doesn't mean that there is ready, solution is ready, it's not ready. It needs to be found out by by way of application from solver. There we have combination of over constraining or under constraining, is a system of solving. Well, here is a sample of solver constraints that means to be solved, is a way of decision making support. And here we presented the architecture of a service adapter that allows overcoming from database level to knowledge-based level with developed parameter service. So we presented the samples of case-based reasoning combined with constraint satisfaction methodological aspects that allows combining data and knowledge models in the industrial fields of wealth drilling. Thank you for your attention.